Good day, welcome to Unit 1, Physical Sciences. What we will focus on in this case is Paper 1. We're not going to go to the beginning of the definitions, the principles, and anything that is relating to the calculations. I would recommend that the following things need to be, I've assumed, to be in place for you to understand this section. My name is Prosper Ngomo. I will be your Physics Paper 1 tutor. I hope you enjoy the sessions. Let's go right into it. Unit 1, we're going to focus on the laws of motion. What's expected of you to know before you go into an exam or to try out any question. Normally, the laws of motion mechanics is focusing on the Newton's laws of motion, all four of them. So my recommendation is this, prior to you going through this episode, it will be very much important for you to refer back to grade 11 where you studied the vectors. Remember, vectors, we say that are quantities that have got both magnitude and direction. So it will be good for you to go back to do revision on that, because for you to fully understand how exactly the mechanics of the Newton's laws of motion work, you will need to first fully understand the subject of the vectors. So I will recommend you to go back to study on that. The second aspect that we will look at, we're also going to look at what are forces. If you go back to grade 10, grade 11, you define a force as a push or a pull, and there are different types of forces. So part of which, if you are going to attempt these questions, it will be very important for you to go back and study that. We have got different types of forces that we'll be looking at, namely the weight. We also have got the weight, which is a force that is caused by a gravitational pull on any body on the surface of the earth. We also have got what are called applied forces. We're going to go through all of that. We also have got the force of friction, which is the force that is opposing motion. And then we're also going to look at tension, which is the force that is exhibited by a string. All right. The fourth thing that we're going to look at in this episode will be the force diagrams and free body diagrams. It is very much important for you to go back and look at the difference between the force diagrams and the free body diagram. I'm not going to go into the detail of those notes because we will focus directly on the revision. I will help you work on the questions for paper 1. Right. We're also going to look at the resultant force. It's very important for you to go back and study what a resultant, or what we call a net force, is. It is very important for you to go back and just do a quick study on it before you even attempt any questions. The next thing that you need to also be aware of is Newton's first law of motion. It will be important for you to go back and re-look at the Newton's first law of motion in detail prior to attempting these problems. Remember that Newton's first law of motion specifies that if a body is at rest, it will continue to do so. If it's moving, it will continue also to do so at a constant velocity in a straight line, unless and until it's acted upon by a non-zero net force. It's important for you to remember that before you even attempt any questions in paper 1, question number 2. The other thing that we're going to look at is the velocity and acceleration. It is very important for you to go back to that and analyze what velocity is and what acceleration is. These being the vectors, they play a big role whenever you are going to understand the mechanics of the Newton's laws of motion. The other thing that you need to go and study is the Newton's second law of motion in terms of acceleration. We are saying that if a force is applied on an object, the object is likely to accelerate if its net force is not zero. So whenever the net force is not zero, mark those words. Then you apply a force, the body will then accelerate. And it is said that the acceleration will be directly proportional to the magnitude of the force that is applied, and inversely proportional to the mass of the object. That is very much important. We're going to go and look at that. The other thing that we need to go back and revise is Newton's third law of motion, which is whenever you apply a force on a body, the body will exert the same amount of force in the opposite direction. It's very important for you to go and study that and prep before you prep for any exam in physics paper 1. We're also going to look at the Newton's law of universal gravitation, which is mentioning that always objects are in constant attraction to one another. Like in this case, on any form of a universe, it is said that the amount of attraction, the force of attraction that exists, is directly proportional to the product of their masses and inversely proportional to the square of their distance apart. It is very important for you to practice that before we attempt any problems on mechanics. The last thing that's very important for you to understand is the difference between mass and weight. The difference being mass is generally a scalar, and then weight is a vector. What it means is mass only contains a magnitude, but does not have to specify the ideas of gravity or the direction of the pull. On the other end, weight is the same as mass in a way, but it's more of a vector, which needs you to specify both the gravity, direction, and also the magnitude that is applied on an object. It will be very important for you to go back to these elements prior to attempting questions in physics paper 1. All right, so without any further ado, what I will do, I'll try and help you understand and give you some hints and tips on how you can be able to approach questions that are relating to mechanics or Newton's laws of motion. So what I did, I went and pulled a paper 2023, the May-June paper. I want us to go through it in detail. Right, so let's go right into it. What you see in front of you, it's block A, which has a mass M. And this object is not specified in terms of what is the magnitude of the force M. And then it is said it is connected using a string, as you all can see. All the way is connected to a second object, and they are running over a pulley system, and is connected to the object that is 7.5 kg. Take note that both objects are subjected to gravity, therefore they possess the weight. Right, so block A of mass M is connected to block B of mass 7.5 kg by a light inextensible string. It's very important for you to be aware that whenever the string is inextensible, we are taking rid of the subject of stretching and elasticity. So in this case, it's non-elastic, or let me say it does not stretch. As a result, it exhibits a force on both blocks, which is the force of tension. So it's passing over a frictionless pulley. It's very important for you to be aware that if it's frictionless, then it means that in your calculations you don't account for friction. And it's also said that block B is initially at a height of 1.5 meters. That is where block B is at. As you can see, it's just off the ground. We're given the ground, we're given the ceiling. So it is above the ground, while block A is initially stationary on the ground, as shown in the diagram below. Right, so when block B is released, once block B is released, what will happen? We expect the block B to be pulled by the force of gravity. Remember the Newton's fourth law that specifies that the object is in constant attraction to another object. In this case, any object that has a mass is generally attracted by the Earth, or depending on where the planet is. In this case, we are on planet Earth. There is a universal gravitational pull more towards the ground. So what will happen to block B? It's going to be pulled all the way down to the ground. We are going to go and attempt the questions, but before we do so, it is very important for you to read the questions carefully before you attempt them, because you're looking for terms like smooth, frictionless. You're also looking for such terms like constant velocity, whether the object is accelerating or not. So in this case, it's specified that you need to ignore the effects of friction. That's very much important. So whenever the block is released, it moves vertically downwards, and it will then go to the ground with a velocity of 3.4 meters per second. So how do we work out? The first question that we're going to attempt is that show by means of calculation that the magnitude of acceleration of block B is given as 3.8 meters per second squared, while the block was moving vertically downwards. So how do we work out on that? Check note that the object, as we can see in the beginning on the diagram, when they are stationary, it is considered to be at an initial velocity of 0 because the object was stationary, it was above the ground. As a result, it is having an initial velocity of 0. And then we want to work out its acceleration as it goes down. If you check previously, we were given the initial velocity as 0, and we're also given the final velocity. So what do we do in that scenario? We are given the acceleration. We just want to prove that the acceleration is 3.38. So what we'll do, check the object. If we go back, you identify that the object, it is said that it hit the ground at 3.41 meters per second, which represents the final velocity. And also it is said that the object was at initial velocity of 0, and it has to cover a displacement of 1.5 meters as it goes down. Let's work it out. So what you will need to do, based on the data that you are given, then you choose the right formula that will help you work out the acceleration. You are given the final velocity, you are given the initial velocity, you are given the displacement, that is the height of the object. So what are you working on? You are looking for acceleration. So you look for the formula that speaks to the final velocity, initial velocity, the acceleration, and the displacement. So there is the formula that we came up with. You will be able to obtain 1 point whenever you do that. 1 mark is dedicated to writing down the formula. So in this case, we identify the formula as the final velocity, which is given by Vf, and then the initial velocity, which is given by Vi, and then you're given the displacement, which is in the vertical direction, which makes it the value change in Y. So what we'll do, we'll then substitute the final velocity, which is the velocity at which it strikes the ground, is equal to the initial velocity, which is 0, because the object is starting from rest and its heat is going down to the ground. And then you're also given the formula 2 multiplied by the acceleration, which is the value we're looking for, and the displacement, which is 1.5. Take note that before you attempt that, make sure that it's in standard SI units. Right. So A, therefore, if you work out and transpose and then make A the subject of the formula, you will then be able to realize that A will give you 3.88 meters per second squared. Right. The second question is asking you to draw a labeled free body diagram showing all the forces that are acting on B. As you can see, body B, the first force that we expect there is its weight going downwards, and then also it's held by a second force, which is the tension on the string. So what we expect in this case, they never mentioned anything about the forces that are coming sideways. As a result, there are only two, one vertically upwards and the other one is vertically downwards. Hence, we came up with this free body diagram. Whenever you're drawing the free body diagram, it's very important for you to identify the object as a point. You just put a dot to represent an object. And then in this case, the object is subjected to gravity. That's why we put this W to show that it's pulled by the gravitational pull downwards. And then it is resisted by the tension of the string, which is pointing upwards. There is 1 mark for each one of the forces that you will draw. Take note that every time whenever you ask the questions around the free body diagram or the force diagram, the number of marks should give you a hint as to how many forces you're expected to come up with. All right, so this brings us to question number 2.3. Question number 2.3, it says that state Newton's second law of motion in words. Right. As we say that the Newton's second law of motion specifies that whenever a net zero force is acting on an object, the object is likely to accelerate in the direction of the applied force, in the direction of the bigger net force. that acceleration is directly proportional to the force that was applied to it and is inversely proportional to the mass of the object. Make sure that you go back and re-look, revise, and don't cram. Fully understand what it means, and you highlight the key points of the definitions and these principles before you attempt any questions. Let's go straight to question number 4. The question number 4 is asking you to calculate the value of m by applying the Newton's second law of motion to each block while they are in motion. Right, take note that this is what we call a system. It's not a single body system. It's two bodies. Therefore, we call it a system. In that scenario, it means that because the two bodies are held together by a rope or a string, you will need to work them out independently and then come up with a simultaneous equation that then works out the results. But in some scenarios, you won't need simultaneous equations, right? In this case, the first thing that we identify is that you need to specify the direction, whether it's positive or negative. Any problem in mechanics, you can't come up with an assumption. Don't even attempt to answer any question until you fully determine the convention direction. Like in this case, I will choose the downward motion as positive. And because the downward motion is positive, all vectors such as the velocity, such as the acceleration, such as the weight, will then assume the direction as positive, downwards. So because of that, we are going to say that the F net is given by mass times acceleration, which is Newton's second law of motion. And then in this case, it is said that the F net is represented by the sum of all the forces that are acting on the object. Like in this case, there is a force of gravity and the tension on the rope. And because of that, that gives you the F net, which is equal to mass times acceleration. The gravity is given by the mass and gravity, which is the gravitational constant, 9.8. And then you have the tension is equal to mass times acceleration. Observe something here. There is a negative. The reason is because the tension is going in the opposite direction of your convention that you chose. If you conventionally chose that the downward motion is positive, we expect that all forces facing upwards will then be negative. Right. So as you can see, mg is represented by the weight, which is positive. Why? Because it's facing downwards, minus tension, which is facing upwards, is given by mass times acceleration. Let's go ahead and substitute that. You will notice that the mass is given by 7.5, and then the g is calculated as 9.8, minus the tension is equal to 7.5, which is the mass times the acceleration, which we calculated in the previous question. So based on that, we can then work out the amount or the magnitude of the tension on the string. If you apply some rules of mathematics where you are transposing all values or you're collecting the like terms, all values will go to the right, and then eventually it zeroes down to the value of T, which is 44 newtons. Right. It's always very important for you to highlight the units of measurements. Don't lose marks based on forgetting the units of measurements. Right. So now that we've got the value of T, we can proceed to work out the mass, right, of A. Take note that the first part we focused on the first object, which is 6.5 kg, and because they are on a single system, they are accelerating together at once. Now that you have got the value of T, you can now go ahead and work out on the mass. So how do we do so? We also go back to the F net is equal to MA. Our net force now acting on the object M is given by mg minus T equal to mass times acceleration. Based on substitution, we can conclude that the mass of the object, which is what we're looking for, multiplied by 9.8, minus the tension, which is the value we got previously, is given by mass times the acceleration. So if you work out your mathematics there, you will notice that transposing and making m the subject of the formula will give you the mass 3.25 kg. So that's how you work out on a system. You will work with them independently per object. Like in this case, you have got object A and object B. Object B helped us work out the tension, and then we use the same tension to work out the mass for object A. Right, let's go to the question number 5. Question number 5 is asking you to calculate the maximum height above the ground reached by object A. Now you have worked out the tension, you have worked out the acceleration, you have worked out on all other components. So what we will do, we will then use the formula that we used in the previous way. You've got the final velocity, the initial velocity, the acceleration you already have, and then you will substitute accordingly. 0.2 is going to be the final velocity, and then you also have got the initial velocity, which was given by 3.41 squared, is then plus 2 times the acceleration worked out times delta y. What it means is that the object is accelerating due to gravity, therefore the A is given as 9.8 meters. If you make y the subject of the formula, you will notice that the object reached the highest position, or it was thrown off a little bit by 0.59 meters. Based on that, we can conclude that therefore the maximum height is going to be the height it reached when it was projected plus the height where it started from, which is 1.5 meters. Right. So in this case, it touched a little bit on the vertical projectile motion, which we will come to it on unit number 3 on the next section. I guess you have got a picture of how you work out the first problem. I also have got the second question, which is taken from November 2022. We are going to have the same system, so you will use the same manner. You have got block P and then block Q. You are working based on that. The key components that you have to identify is the system. Is it accelerating or not? If it's accelerating, you use the acceleration that's given. If it's not acceleration, then we can conclude that the F net will be 0. Right. So in this case, you are given the question as it is based on this system. If you come back to attempt the question, the first question is asking you to specify Newton's second law of motion. We're not going to go to that. The second question is saying that draw a fully labeled body diagram for this block P. As you can see, block P is subjected to the gravity, which is downwards, and then there is a string that is acting on the right, and then every gravity, if an object is sitting on a surface, it has a normal force which is acting in the opposite direction. So eventually we can conclude that therefore our free body diagram looks exactly like that. So what we've got the normal force that is acting vertically upwards, the weight that is acting downwards, and then we do have the tension on the string that is acting to the right. And then because of friction, the question mentioned that this body is subjected to friction. Therefore, we have the friction, which we call in this case the kinetic friction. Right. So let's move on to the question. Question number 1 is asking you to calculate the tension in the string. Right. So what we will do, we will first determine conventionally, like we said in the previous question, you determine the direction in which you will choose as positive or as negative. In this case, because we will choose the right as positive, all the forces pointing to the right will be positive, and the ones that are pointing on the left will then be negative. Right. So in this case, the F net is given by MA, is the object accelerating or moving at a constant velocity. If it's moving at a constant velocity, it means that the F net will be 0. But if it's not, we will then work out the F net, which is taken from the tension on the string pointing to the right. And then there is a resistance of friction, which is going to the left. No wonder you see this negative. F is given by mass times the acceleration. right? So if we proceed, you notice that the tension is given by T, the friction we were given as 1.8 newtons is equal to 1.25, which is the mass of block P, and then multiply that by the acceleration. Working it out will result in T being given by 1.93 newtons, right? So it's very important for you to work out the direction first before you attempt the problem, right? So let's work out the angle theta. Angle theta is subjected on a force that is acting on block number 2, which is block Q. For you to work out that, we're going to also use the same principle that F net is given by MA, and then we can conclude something that's very interesting here is this. F is not directly pointing to the right, therefore it has a component. Remember in the opening session I said that revisit your vectors so well, so that you understand that if a force is acting at an angle, then you resolve it to the components. Like in this case, the component of this force, it has a horizontal component, which is given by force cos theta minus T minus F equal to mass times acceleration. So in this case, the tension on the string is going to be the same tension that we worked out above. And then the friction, you were given the friction, is equal to mass times acceleration. So as a result, we then conclude that 7.5, which is the mass, cos theta, minus 1.93, which is the tension on the string, minus the friction, which is given as 2.2, will result in the mass 2 times the acceleration of the system. This results to the value that theta is given by 54.74 degrees. Take note that sometimes it happens that due to truncation error, you might end up having a difference of maybe 0.5, but we normally give you a range. Right. I guess you get the picture of where things are. I want you to attempt the 2 problems that I just showed you. I will give you some time to work on them and also work them out in that manner. Use the same principle and go through each one of them. Right, so this brings us to the end of our first session. I hope you enjoy and I hope you get the best of your results. Just in conclusion of what we covered the Newton's laws of motion and we attempted the problems thereof. I want you to go and practice the questions in November 2021 paper, and you do the same also with the next question that we will present. In our next topic, I will give you, we are going to move on to momentum and impulse. In these 2 sections, we will look at what momentum is, the changes in momentum, Newton's second law of motion. We will revisit it, but this time we will look at it from the perspective of momentum and impulse. And then we will define what impulse is. We will look at the principles of conservation of linear momentum. We will look at different types of problems that are generally asked. And finally, we will look at the elastic and inelastic collision. I hope you enjoy the session, and I'm looking forward to having you in the next session. Have a good day.